Hello everyone, welcome back to Code Compass. Today we are continuing with the Leetcode Top Interview 150 list, and today we will be solving best time to buy and sell stock. It's quite an easy problem. Let's go to the problem statement. So it says we are given an array prices where prices of I is the price of a given stock on the ith day. So we want to maximize the profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So basically we have the list of prices of the stocks on the various days, and we want to maximize our profit basically by picking a day where we want to purchase the stock and then a day after the purchasing day where we want to sell the stock. And the idea is to choose these dates in such a manner that our overall profit will be maximized. So let's take this particular example, 715364, and the output expected is 5, and the explanation is that if we buy on day number 2 when the price is 1, so over here the price of the stock is 1, we buy on this particular day and then we sell on day number 5. So day number 5 is this, when the stock value is 6. So on that day the value is 6, so profit will become 6 minus 1, which is 5. So there is no other combination in this array where your profit can be more than 5. So that is our entire idea. And let's check the second example they have given. So in the second example, the value of the stock is always basically falling. So there is no way for you to return any profit in this particular example. So the output will be 0, and that is what they have called out also. Like if you cannot achieve any profit, we should simply return 0. So let's go to the intuition of this problem, and we will try to understand what exactly needs to be done over here. Alright, so now let's try to understand the intuition behind this problem. So for that, I have picked the example number 1 given in the problem itself, and let's try to remember what our restrictions are. So basically, we have to buy a stock first prior to selling it, obviously. So if you want to sell something, you have to buy it first. So it's not possible that you will basically sell something at position number let's say 5 and you are actually buying it at position number 6. So that is not allowed. You first have to buy the stock, only then you can sell it. And the second restriction is that you can only do this operation once. So basically, no matter how long our prices array is, we can only sell the stocks once and we can only buy the stocks once. So let's try to see what is my maximum possible gain if I sell it. If I try to see like at each position how much gain I can get by selling the stock. So this is our prices array. Okay, I'm writing it like this: 7, 1, 5, 3, 6 and 4. So let's say I try to sell my stock set, and over here I will also write the indices of the array: 0, 1, 2, 3, 4 and 5. So let's say I try to sell my stocks at position number 0. So obviously I will not get any profit because this is the first day itself. So my maximum profit will be over here 0. Now let's see if I try to sell at position number 1. So at position number 1, what are my options where I must have bought the stock? So the only possible option is position number 0, which is 7. So I bought at 7 and I sold at 1. So my only possible profit is 1 minus 7, which is a loss of actually 6 rupees. So I will be losing money. Now let's see what happens if I try to sell my stocks at position number 2. So at position number 2, the stock price is 5. So I might have bought the stocks at position 0, which is 7. The value was 7, or at position number 1, which is 1. So obviously, if I am trying to maximize my profit, I would always try to purchase the stocks at the lowest possible value, right? Preceding the current day's value. So current day value is 5, and what is the lowest possible value prior to 5? That is 1. So my maximum achievable profit will be 5 minus 1. So if you try to look more closely, there's a pattern building here, and the pattern is that for every position, if you want to maximize your profit, you have to find out what was the smallest value of the stock prior to that day. Now let's complete this example, then it will become more clear. So let's say I try to sell at this position number 3. The stock price on that day is 3. So I must have bought the stock at either position 0, 1 or 2. Now you tell me, like, what would be your maximum achievable profit? That will obviously be if you bought at this particular position, which is when the stock value was 1, and at that point, if you are selling on this day, your maximum profit will be 3 minus 1, which is 2. So let's say you bought at position number 2, the stock price was 5, so you will be at a loss of 2 rupees. But the problem is asking us to maximize our profit. So we will always want to find out what was the minimum possible value prior to the selling day. Now let's go to position number 4. Over here the stock price is 6, and I will obviously want that I purchased on position number 1. So maximum achievable profit over here will be 6 minus 1, which is 5. And similarly at last point, which is the stock value is 4, I would want that I must have bought the stocks at position number 1. So the profit here will be 4 minus 1, 3. So now this is not your final answer. These are all the possible profits that you can make depending on which day you are selling your stocks on. And since we want to maximize it, so I can simply take a maximum of all of these positions, and that will be my overall solution. So if I take a maximum of 0, minus 6, 4, 2, 5 and 3, that will come out to be 5, which is same as this. So now let's try to expand this and do a complete dry run so that we know what all values are getting updated and how our result is getting updated at each index. So since we cannot right away tell what my minimum was given to a prior position, I will basically introduce a variable which will be minimum. So this variable is nothing but it denotes the minimum possible value in the prices array preceding that particular position. Listen to this again. So minimum of I will basically tell us smallest value in the prices array preceding to ith index. As simple as that. So what we will do in starting, we will initialize minimum with the first value of the index, first value of prices array. Why? Because obviously we are starting from the day 1, and at day 1 what is the minimum value of the stock that you can get? That will obviously be whatever the stock value is on day number 1. And at I is equal to 0, prices of I will also be 7, right? And result, I will tell you how we will calculate the result. So we need to take care of two things. Number 1 is we need to keep calculating result, which is these values at each step, and keep updating it. And side by side, we will also have to keep updating minimum because it will be used in the next iteration. So there are only two operations that we will be doing. So first of all, we will be updating result as maximum of result, comma. Otherwise, either our current result will be greater, or I will check whether my current price minus minimum is greater. So it's possible that basically compare it with this small dry run over here. So at here result will be 0. At next step it will be minus 6. So these two will be compared and it will keep getting updated. Then minus 6 will be compared with 4 and 2 and so on and so forth. And second step would be updating the minimum variable. So it will simply be minimum of whatever is the current minimum value and the ith price value. So let's see it happening in action, then things will become much more clear. Okay, so at I is equal to 0, result will obviously be 0, because if you are buying on the same day and selling on the same day, your result is anyway going to be 0. So let's just put it as 0 over here. Now let's come to I is equal to 1, which is this value. So at I is equal to 1, and minimum will be updated as minimum comma prices of I. So this will become 7. At I is equal to 1, prices of I is 1, and result will be maximum of this value 0, comma 1 minus 7. So this will be still be 0, because 1 minus 7 will be minus 6, and out of 0 and minus 6, 0 will win. And then let's go to I is equal to 2, which is 5. So but prior to that, minimum will get updated. So minimum will be minimum of 7 comma 1. So this will become 1, minimum becomes 1. At I is equal to 2, price's value is 5. Now let's recalculate the result. So previous result is 0 and our now next option is 5 minus 1. So this becomes 4 because 5 minus 1 I can attain a maximum profit of 4 over here. So this becomes 4. For I is equal to 3, minimum gets updated as minimum of 1 comma 5. So this will become 1. Prices at third index, the value is 3. Now we update the result. It will be maximum of 4 comma 3 minus 1. So this will be 4 because 3 minus 1 will be 2 and out of 2 and 4, 4 will. At I is equal to 4, minimum will again get updated, minimum of 1 comma 3. So this will still be 1 and at I is equal to 4, this value is 6. So now we recalculate result. So result will be maximum of 4 comma 6 minus 1. So 6 minus 1 is 5. So and out of 4 and 5, 5 will win. Similarly, at I is equal to 5, minimum will again get updated as minimum of 1 comma 6. It will be 1 and at I is equal to 5, which is this value, prices, the value of the stock is 4. And as the last step, we will again update result as maximum of either 5, which is this, or 4 minus 1. So maximum of 5 comma 3, 5 will win here, and that is our overall solution. So just take a few minutes, go back and read, watch this dry run again, then things will become much more clear. And now let's see the code for this solution. Alright, so now that we properly understand the intuition for this problem, let's try to convert it into code. So let's start from the very beginning. I will start by introducing the two variables that we had discussed. First one will be the minimum, which will be tracking. I will be initializing this with 0, the very first. This will be tracking the minimum seen so far in prices array preceding the, or let's call it as prior to ith index. That's it. And the second variable will be the result. We will initialize this with 0 and in the end we will simply return the result. Now let's start traversing the array. So I will start with the first day because again if we start from the very 0th position, it will be the same buying price and selling price. It will not matter much. So I'm starting from the first index. So at each index, just try to recall what we were doing when we were understanding the intuition. So I will first of all update my result as maximum of my current result and the result that I get at this particular index, and that will be the value of stock on this particular day versus the minimum value of stock I have seen so far prior to ith position, and that will be contained in minimum. Once you do that, you have compared the previous result with the maximum possible result at this particular index, and afterwards we will update the minimum value for the next iteration, and that will be minimum of the already minimum value and the current value of the stock. Simple. So let's see if this one works. Great. So the base 2 test cases are passing perfectly. Now let's submit this. Alright, so all our test cases are passing. So I hope the code and intuition both were clear to you. If you liked our content, please subscribe to our channel and I'll see you in the next one.